Part 2, let's talk about example number 4. All right, let's talk about this question. I see a trig function squared. I see another trig function that's not squared. So anytime you guys have a quadratic, if you have something squared, we want to move everything to one side and try and solve. So let's go ahead and move this over. Now again, if we want to think algebraically, we could look at this as y x squared equals 2y. Right? If we move everything over, so say we did this, y x squared minus 2y equals 0. What do you guys notice? What's in common? They both have a y, right? So you would take it out, and then you'd be left with x squared minus 2 equals 0. And then what would you do with each piece? Set it equal to 0 and solve. That's exactly what we're going to do here, right? We have cotangent. So cotangent x times cosine squared x equals 2 cotangent x. Let's move everything to one side. Since it's a quadratic, it's not that you have one trig function. You know, it's on both sides. You're moving one trig function to one side, numbers to another. It's a quadratic, so get everything on one side. So cotangent x, cosine squared x, minus 2 cotangent x, right? When you move it over, it becomes negative, equals 0. So what do they have in common? They each have a what? Okay, so I'm going to divide out a cotangent x from both. Cotangent x. So your cotangent x comes out in front. It doesn't go anywhere. It just goes out in front. And then we're left with what? Cosine squared x, what? Minus 2 equals 0. Perfect. Now you have two things that you can set equal to 0 independently. So I'm going to say cotangent x equals 0 and cosine squared x minus 2 equals 0. Let's solve this one on the right a little more. Cosine squared x equals 2. Agreed? I don't want cosine squared, I want just cosine, so I take the square root. So cosine x equals plus or minus square root 2. Everybody with me? Now that's not the answers, that's telling me where to look. So I look here, I have two different scenarios. The first one says cotangent, which is what over what? Okay. No, it's cosine over sine. But what letters? No, but tell me what letter? X over y, y over x, what? It's x over y. So where on my unit circle would you take the x value, put it over the y, and get 0? Pi over 2 and 3 pi over 2. You take 0 over 1, that's 0. 0 over negative 1, that's 0. So your answer here is pi over 2, 3 pi over 2. Perfect. Now over here, it says the cosine, which is what? X values. Okay, where, guys, on the unit circle are the x values plus or minus square root of 2? This is not a trick question. Do you see any x values that is just either positive or negative square root of 2? No. Is there a solution for this problem? Yes. But is it on the unit circle? No. So you can just cross it off. You can get a solution for that, but you have to use a calculator. We're not using one. We're only using the unit circle to answer. So if you come up with something and it's like cosine x equals 7, is there any place on the unit circle where an x value is 7? No. So just cross it off. That's not a valid answer because we're only talking about stuff on the unit circle. Does that make sense? It's still your x value, but there's not a place on the unit circle that has an x value that's square root of 2. You'd have to use a calculator. All right. Okay, this is where we were. Now, guys, go ahead and move to number 10. I kind of want to do this. It makes more sense in this order. All right, number 10. This is the same kind of a problem. Now, let's look at it. Do you guys see that this is a quadratic? Why is this a quadratic? Because one function squared, one is not. So what the first thing you should do when it's a quadratic, you know you're going to have to factor it. What should we do with everything? Bring it all to one side. So I have secant squared x minus 2 tangent x. Do you guys agree it's minus 4 when we bring this 4 over? Yes. Okay. So we had one of these yesterday. I have a trig function squared, one that's not. I know it's a factoring problem, but I can't factor it exactly how it is. I have to convert. So they're both the same. I told you to always convert to the middle one. Convert to the one that's to the first power. So look at your identities. What's the relationship between secant squared, and is there something that has a tangent in it? Your Pythagorean identity?
So it would be secant squared minus 1 would equal tan squared.
So we want to change it to tangent.
Oh, tan squared plus 1.
So tan squared, do you guys agree that tan squared plus 1 is the same as secant squared? Everybody with me? And then we're just going to rewrite the problem. Minus 2 tangent x minus 4 equals 0. Everybody okay? Okay, so now I'm going to say I have tangent squared plus 1 minus 2 tan x minus 4 equals 0. Nothing to distribute or anything like that. Do you guys have anything you can combine? Positive 1 and a negative 4. So tan squared x minus 2 tan x minus 3 equals 0. Everybody all right? Okay, so we're going to factor this. What's going to go in the front of each parenthesis? Tan, good. What are the factors of negative 3? That'll multiply to give me a negative 3, but add to give me a negative 2. Minus 3n plus 1. Yeah? You guys with me? Okay, so now we're going to set each equal to 0 and what? Solve. So here I have tangent x, you guys agree it equals 3? And then over here I have tangent x equals what? Negative 1. All right, so let's remind ourselves that's not the answer. That's telling us where to look on the unit circle. So what is tangent? What over what? Y over x. Is there anywhere on the unit circle, guys, that you could take the y value, put it over the x, and get the whole number 3? No. Is tangent of 3, and yes, you could solve this, but you'd need a what? Calculator, which you guys aren't going to use. So now I come over here. Tangent is still y over x. Where on my unit circle, we talked about this yesterday, could you get a tangent of either 1 or negative 1? Well, what does the ordered pair have to look like? No, for tangent to be 1 or negative 1? It's got to be radical 2 over 2, radical 2 over 2, right? One of them has to be negative, and one of them has to be positive. So where on the unit circle is that? It should be the over 4s. Okay, 3 pi over 4 and? Okay. I don't have my unit circle in front of me. Is that correct? Remember, anything divided by itself is what? 1. We're not looking for 0. We're not looking for undefined. We're looking for 1. So for those factoring ones, guys, as soon as you see something squared and something to the first power, just move everything to one side, convert it all, and solve. Scooting along. Let's do 8. Actually, no. Hold on. All right, let's do the last 2. I want to do number 8 first. There's one difference in number 8 with all of the other problems we've been doing. Okay. With this cosine and the t, what is the one difference you see? There's a 3. Do you guys see that 3 in the front of t? Every other problem, it's been x, theta, t, whatever, but there's no coefficient of it. This is called a multiple angles problem. This involves one extra step. Let's work it out. How would I get what I have highlighted all by itself? I want to add 1. So I have 2 cosine 3t equals 1. I want to get this all by itself. Divide by 2. Okay, I can't divide by 3 because that 3 is stuck in between the cosine and the angle. So here's where this is a little different. Because what we have been doing, right? Where am I going to look? What does cosine mean? Cosine's x values. Right? Cosine's x values. So every time we've done this, we would answer and we'd say x equals, right? But we're not finding x equals or t equals. What are we finding? 3t. So you're just going to, one extra step, you're going to say 3t equals. So where on my unit circle are your x values positive 1/2? At pi over 3 and? Okay. So the extra step is now, guys, you've got to get t by itself. So what would you do? You divide by 3. When you divide by 3, it's the same as multiplying by what? Because look, you're going to divide by 3 over 1, correct? Divide by 3 over 1. So you're ending up going to keep, change, what? Flip. So this really becomes, what is your answer? Pi over 9. You're fine. And then here, I'm going to keep, change, flip, and this becomes 5 pi over 9. So when you have a number stuck right here, you work it out the exact same way. The only thing is once you find the angles, it's not x equals, it's whatever that is, 4t equals, or, you know, whatever, and then you have to do one more algebraic step. That's all that is. All right, last one, and then we're finito. This is the hardest one that we'll do, and it's just because it's a little bit of algebra to it. You'll probably have one of these maybe on your test, maybe not. We have not encountered one that looks just like this, so let's talk about it. Cosine x plus 1 equals sine x. The first step is the hardest part to understand what to do, and then everything else is just algebra. All right, if I move everything, nothing is squared, right? So I can't like change anything yet. I can't use a Pythagorean identity. If I move everything to one side, is that going to help me at all? No.
Could you make it a Pythagorean?
We could make it a Pythagorean identity, yes.
We did this one yesterday.
No, we didn't.
No, we didn't.
We skipped number 4, right? Because I have all the work for this one, and I don't think I did it myself.
I didn't do this one yesterday. I did number 4 first today.
Okay, thank you.
That's okay. All right, so the first thing I'm going to do is I'm going to say, I want to leave cosine. Whatever function is here, just leave it. I'm going to move this over here. So I'm going to keep my cosine, and I'm going to say sine x minus 1. You guys with me? And now we're going to square both sides. Why are we going to square both sides? We're going to create an identity. Whenever you guys, so when we do this, you guys, we have cosine squared here. And when I FOIL this out, it doesn't become, think about what this is. I'm going to write it out so you guys don't make a silly algebra mistake. This is sine x minus 1 times sine x minus 1, right? When I FOIL, what's sine times sine? Sine squared. What's sine times negative x? Yep. What's negative 1 times sine? Negative sine x, right? And then negative 1 and negative 1 is plus 1. All right, the signs don't cancel here, guys, because you're multiplying by the same thing. So let's just clean it up a little bit. So you have your cosine squared. Here we have sine squared. How many negative sine x's do I have? Good. Minus 2 sine x plus 1. Now you guys are like, okay, how did that help us at all? Do you now have a trig function squared and 1 to the first power? Yes. So we should do what with everything? Put it all on one side. I don't care where you guys move. Do you want to move the cosine to the right, or do you want to move everything else to the left? Cosine to the right. Okay, so when we do that, guys, just make sure you're paying attention here. Do you agree with me? This becomes negative cosine. Okay? So plus sine squared minus 2 sine x plus 1. What would my next step be?
Convert the cosine to the sine.
Perfect. What are we converting that cosine square to?
To sine squared minus 1. Or plus 1.
No.
1 minus
1 minus. You were close. You were close. And again, I'm going to give you that identity sheet that has everything all manipulated around. We're taking this cosine and we're converting it here. Do you see why I have that negative out in front?
Yeah.
Because we moved the cosine to the right. So then we have plus sine squared minus 2 sine x plus 1. One more thing before we can start simplifying and all that. Distribute that negative. So this becomes negative 1 plus sine squared minus 2 sine x plus 1. So let's combine like terms. Hold on one sec. Yeah.
So as long as we're doing it to both sides, sides, we can manipulate it and then.
What happens with my positive 1 and negative 1? Cancels, good. How many sine squareds do I have? I have 2 sine squareds minus 2 sine x. And how do we think always, guys? Algebraically. What do you notice they both have in common? A 2 sine x, right? So if I divide out a 2 sine x here and a 2 sine x here, what am I left with? Sine x minus 1 equals 0. Now you have it fully factored. What do I do with my 2 little pieces that I have left over here? Set them both equal to? Perfect. So when I divide, obviously both sides by 2, I just have sine x equals 0. And here, when I move this over, I have sine x equals 1. So again, we have not answered the question yet. What am I looking for on my unit circle? What values? The y's. I'm looking on my unit circle for the y values of 0 and positive 1. Where are my y values? 0. My y value, 0, would be where? My y value, 0. Okay, sorry. So I have x equals what? My y value of 0 is where? Pi and 2 pi. What's another way we can write 2 pi? Okay. And then I also have a y value of what? Positive 1, which is where? Perfect.